One of the most amazing natural events of our time happened on January 15th, 2022, when a volcano in the southwest Pacific Ocean called Hunga Ha'apai, Hunga Tonga, violently erupted. This was the most powerful volcanic eruption in the past 30 years or so, and the first of its kind recorded on a wide range of modern scientific instruments. The explosion shot a plume of ash high into the atmosphere, higher than any eruption since 2006, when satellites capable of measuring eruption column heights were in orbit. It caused a kind of a sonic boom that had not been recorded since atmospheric testing of nuclear weapons ended in the early 1960s, and it also caused a strong tsunami. UT Dallas Geoscience Studios quickly made a video, and our efforts led to an interesting chain of events about how science is done, with collaboration, disappointment, and success. It is a story that we hope you will find to be interesting. The story focuses on the activities of three geoscientists, in order of appearance: Bob Stern, Cornel Durand, and Shane Cronin. One American and two New Zealanders. Bob is at the University of Texas at Dallas and head of Geoscience Studios, which made this video. Cornel is a research geologist at GNS, a government institute in New Zealand that studies submarine volcanoes like Hunga Ha'apai, Hunga Tonga. Shane is professor of volcanology at the University of Auckland in New Zealand. The story begins shortly after the eruption when Bob emailed Cornel and asked what he knew about changes in the submarine parts of the volcano. The January 15 eruption was so violent that it must have greatly reshaped the volcano, but these changes were hidden under the sea. There are all sorts of tools for determining what happens above sea level, but not for what happens underwater. German, American, and New Zealand colleagues had used ships equipped with multi-beam echo sounders to survey the submarine volcano before the eruption, but it would require time and money to hire a similarly equipped ship to resurvey it. Cornel suggested that he and Bob write a proposal to take a multi-beam equipped ship to the volcano and see how the eruption had changed it. Bob knew that the only source of financial support in the U.S. for research projects like this was the National Science Foundation, or NSF. NSF is a U.S. government agency that was founded in 1950 with a mission to promote the progress of science. U.S. scientists in many fields submit proposals for all kinds of research projects they want NSF to fund. It takes a lot of time and effort to write a normal NSF proposal, which is reviewed by several experts in the field as well as a panel of scientists before NSF reaches a decision to fund or decline a proposal. The process takes time, generally between 6 months and a year, too long to wait for a project like this. NSF has another funding mechanism called Rapid Response Research, or RAPID. NSF Rapid Grants are designed to support quick response research along the lines of what Bob and Cornel wanted to do. They are shorter and reviewed faster than a normal NSF proposal. Cornel found out what ship could be hired, settling on the small research vessel Kaharoa. This vessel was not equipped with the multi-beam sonar needed to survey the volcano, so Cornel found out what it would cost for this to be rented from a company called Fugro and have installed on the hull of the vessel. Meanwhile, Bob reached out to NSF to find out if they would be interested in a rapid proposal to survey Hunga Ha'apai, Hunga Tonga. They were, so Bob and Cornel went to work on the proposal, submitting it in early March. It was quickly approved, and on April 5th, Cornel and a small team sailed on the Kaharoa from Wellington, New Zealand, northwards towards the volcano. The voyage began well enough, but a few days out of port, a serious problem appeared. They were about 50 nautical miles north of East Cape, New Zealand, when they turned on the sonar for its daily systems check, only to find out it wasn't working. So they turned around and headed back to Hicks Bay to get commercial divers to check the hull to see if there was any obvious structural problem. The divers found that the entire multi-beam unit had disappeared and fragments of wood were jammed into the mount for the unit. It appears that the sonar was ripped off when the ship sailed over a submerged log that had been washed out to sea by a once-in-a-century flood event that had happened on East Cape about 10 days earlier. With the loss of the sonar, this attempt to map the new Hunga Ha'apai Hunga Tonga caldera was stymied. Fortunately, and unknown to Cornell and Bob, Shane was on Nuku'alofa, just 65 kilometers from the volcano, and was also making plans to map it. On April 9th, he used a 9-meter fishing boat that was equipped with a sonar that could see down to 300 meters depth and went over the caldera with it. But he couldn't find the seafloor. 10 days later, he used a Tonga Navy patrol boat with an 800-meter depth sonar, but still couldn't see the bottom. Finally, he arranged for a bigger boat, the 19-meter Pac Horizon, and borrowed an 80 kilohertz sonar that could penetrate deeper. He spent several days adapting it to fit on the Pac Horizon. It took about a week to modify and manufacture the mount, and another 3 days to attach it to the boat and test the system. The survey team, consisting of Shane and 4 geoscientists from the Tongan Geological Services, set sail at dawn on May 17th and headed for the volcano, reaching it in a few hours. They arrived and launched a drone to have a better look at the remnants of the volcano exposed on the island of Hunga Ha'apai. This little island and the smaller island of Hunga Tonga are all that remain of the caldera rim. You can see several levels of different colored lavas and pyroclastic deposits which dip away from the caldera. These dipping volcanic rocks testify that a tall volcano once existed where a 4-kilometer-wide caldera sits today. The drone also took a closer look at some of the volcanic rocks. The uppermost white and cream layers are from the many birds that have enjoyed the island during the last 1,000 years, since the eruption that formed the underlying red unit. The red pyroclastic unit overlies a gray layered sequence, thought to have formed from an eruption about 2,000 years ago. Below this is block lava, which appears to be pillowed and thus erupted underwater. These layers tell about a volcano that grew to rise above sea level and then blew its top to form a caldera sometime in the last millennium. Interestingly, no blanketing ash from the January 2022 eruption is seen. That was a very powerful blast not to leave any volcanic ash around the caldera it came from. The swath mapping progressed well, and the team was able to map the caldera floor in 3 days. There was also time for fun, for fishing, for bird watching, and for swimming. But the real work was to map the caldera, and that was successful. The survey revealed that the caldera floor had dropped about 700 meters. The January 15th eruption had removed 6.5 kilometers of rock and magma, but had caused minor changes to the caldera diameter. This is a stupendous change in volume, equivalent to removing about 6,500 Empire State Buildings all at once. Change in caldera floor depth was tremendous. The Empire State Building would rise from the new caldera floor only about halfway to where the old floor was. Only the tallest building in the world, the Burj Khalifa, would reach from the new caldera floor to where it used to be. We don't have very many before and after eruption comparisons of calderas, but this is definitely one of the big events. Greater than the 1883 Krakatoa eruption, but smaller than the 1815 Tambora eruption. It's a good thing that the caldera was surveyed as soon as it could be, because it might be filling with new lava. The sonar survey discovered some reflective plumes near the caldera floor, possibly due to ongoing submarine eruptions or more likely hydrothermal plumes. Research on the volcano is not done yet. More work is needed to see what is happening now on the caldera floor. After 3 days of work, the Pac Horizon returned to Nuku'alofa. We hope you enjoyed our story of 3 disappointments that finally led to success. This is what real science is like. Our efforts to do something new are often unsuccessful at first, but if we learn from our mistakes and keep at it, we are likely to succeed in the end. There's a lot more work to be done on this volcano, but for now it's good to know how big a hole in the ocean the January 2022 eruption caused. Thanks for watching, and as they say goodbye in Tonga, aloha!